This video covers section 5.2 of Math 1324. So we're going to go over example 5. And now for this one, we're going to step away from the compounded interest where a certain period of time is determined, like we did on the previous example, for annually, semi-annually, daily, quarterly, and monthly. And also, based on our calculator answers, we noticed that for daily, we had a little bit more at the end of 1 year. And so now the idea is that if you keep increasing the number of compounding periods, we go to another formula called compounded continuously. So this is like nonstop compounded interest. For that, we use a different formula, like the one we have here. Future value, present value, rate, time, we have the same variables. And then E is just the number that we discussed in chapter 4. Remember, E is approximately 2.71. It is an irrational number, and it comes from taking the limit of something that will be growing as this, as n grows very large. So what happens with this one is that this one will equal, or we may say it will approach E. And so that's why we have a different formula for continuous compounding. And the way you will know which formula to use is because you will find words like the ones I just enclosed in a rectangle. So we have here, suppose that you have $5,000. And you want to invest it at an interest rate of 3.1, so it will be 0.031, and the time is for 4 years. So future value is equal to present value times e to the power RT. And so we're looking here for the future value. We're going to substitute present value here with the 5,000. E is just a number, and then for the rate we have 0.031, and for the time we have 4 years. So what I'm going to do here, when I enter it on the calculator, you may want to enter it like this, 5,000. You could use the multiplication symbol or just press the key with the number E to the power X. If you automatically get that exponent, then just make sure you enter your 0.031 times 4 inside there. Or if you don't get the exponent option after you press the key with E, then make sure you use the caret symbol, and then in parentheses you will enter 0.031 times 4 for 4 years. Or you may use a double parentheses as well. That will work out. So you could do that, and you're going to get an answer of approximately $5,660 with 8 cents. And that is rounding to the nearest cent. Okay, so for the next problem, what we have is a problem involving a zero coupon bond. And so for this type of problems, what happens is that there are no interest payments during the life of the bond. The investor receives a single payment when the bond matures. So this is at the end of the term of the loan. And this will be consisting of the original investment, the present value, and the interest that was already accumulated. And this is typically compounded semi-annually. And a zero coupon bond or bonds are sold at a substantial discount So this is a new word that we're going to use, from their face value. And the buyer receives the face value of the bond when it matures. So that will be when the loan ends, or the bond, I should say. The difference between the face value and the price of the bond is the interest earned. So it's like we're going to be finding a new present value. So we have here this example, number 6. It says Doug bought a 15-0 coupon bond paying 4.5% interest compounded semi-annually for $12,824.50. What is the face value of the bond? So what we need to do here, first, we're gonna analyze every single quantity. So we have T will be equal to 15, and it is already in years. We have the rate of 4.5%, so converted to a decimal is 0.045 because we divide by 100. And it says here the interest is compounded semi-annually, so M will be at 2. Now, the 12,850 is going to be considered our present value. So we will be using the formula future value. That is what we are looking for. So the future value will be present value, parentheses 1 plus R over M, parentheses M times T. So the future value will be, substitute present value with 12,824 and 50 cents. And then we are going to open parentheses here, and we will have 1 plus. However, on the calculator, you want to enclose this fraction in parentheses as well, and that will be the rate 0.045 divided by 4 because, no, not 4, 2, because the interest is compounded semi-annually. We have that here. And then for the exponent, we're going to need 2 for M, and then for the number of years will be 15. So after entering all of that in the calculator, the future value will be 24,999.99618. So what we're going to do is round it to the nearest integer or to the nearest dollar. So that will be 25,000. And so the face value of the bond will be $25,000. Now for the next example, we are going to use the same formula. Present value is equal to 1 plus I to the power n, and this is actually wrong. It is future value is equal to the present value times that. And so for this problem, it says suppose that the inflation rate is 3.5, which means that the overall level of prices is rising 3.5% a year. How many years will it take for the overall level of prices to double? And for this problem, we will consider our present value, just present value. Our future value, however, we want it to be 2 times the present value, or double of the present value. So then when we use our formula that I want to remind you is also this. I is replaced with R over M to the power MT. But now, instead of future value, we're going to use 2 times the present value because we want the prices to double. So for R, of course, we will use 0.035. And the question is how many years, so T will be the question. And we are going to consider the number of compounding periods just to be 1 because it will be assumed to be annually. So we take our formula, future value equals this. And let's just substitute whatever we can. Remember, we are solving for T. So everything else will be substituted with a number or an expression. So for future value, remember we're using 2 times the present value because the question is how long would it take for the prices to double. Present value will just be present value. Here we'll have 1 plus, and we have 0.035. It will be divided by 1, so it's not really necessary for me to write the 1. And then for the exponent, we have 1 times the time, 1 because it's annually. So it's not necessary for me to write the 1. So I'm going to delete that. We'll just have T. Now, first thing I will do here is divide by the present value, just so that I can cancel that variable. And so it's not necessary for us to know what the present value was originally. Here, I'm going to add these 2 quantities, so I will have 1.035 to the power T. And what I can do here is I could take the natural log on both sides. ln, remember you have that quantity, that button on your calculator. Then from here, I will use the power property that tells me I can bring that to the front. So T will be a linear quantity. Here I have the natural log of 1.035. And here we'll have the natural log of 2. Now you could see that everything here, it's multiplying to T. So if I take that across, it will be, this quantity will be dividing. So the natural log of 1.035. And what we already had on the left was the natural log of 2. So if we type that in our calculator, make sure you do have pressed the key natural log twice. 1 for the numerator, 1 for the denominator, and you should get something around 20.14879. And I'm going to stop the video here.